Today we are going to go over problem 9 of exam 1, part 1. Given water with a pressure of 0.7 MPa and a temperature of 250 degrees Celsius, we are going to determine the phase. First, we will draw a PV plot, pressure being in MPa and specific volume being in meters cubed over kilogram. Then we will draw our vapor dome and label the sections, saturated liquid and saturated vapor being under, compressed liquid being to the left, and superheated vapor being to the right. Then we will draw our constant temperature slice, and the constant temperature in this case is 250 degrees Celsius. Next, we will determine our saturation pressure. Taking a look at table C1 and locating the 250 degrees Celsius, we will find the saturated pressure to be 3.973 MPa. Plotting our given pressure of 0.7, which is below 3.973, we can locate where a pressure of 0.7 MPa crosses a constant temperature of 250 degrees Celsius. It crosses in the superheated vapor section of the graph, meaning our phase is superheated vapor. Now we will determine the specific volume for water with a pressure of 0.7 MPa and a temperature of 250 degrees Celsius. It's important to remember that the determined phase was superheated vapor because it will determine what table we will use. In this case, it's table C3. Notice that there is not a column for a pressure of 0.7 MPa, so we must locate the specific volume for both pressures of 0.6 and 0.8 MPa at a temperature of 250 degrees Celsius in order to interpolate. We will first create a chart of our pressures and specific volumes. We have values for pressures of 0.6 and 0.8 MPa, along with their specific volumes of 0.3938 and 0.2931 meters cubed over kilogram. We are looking for a specific volume for a middle pressure value of 0.7 MPa. So we will include that in our chart along with its corresponding Vm. So we have our first, second, and middle terms. Using those terms, we can plug it into the interpolation equation to determine our Vm. Vm is equal to 0.3938 meters cubed over kilograms plus 0.2931 minus 0.3938 meters cubed over kilograms divided by 0.8 minus 0.6 MPa times 0.7 minus 0.6 MPa. From there, we can cancel out the MPa, and our final answer for the specific volume is 0.34345 meters cubed over kilogram. Lastly, we will determine the quality of our water as a decimal. Since the phase is superheated vapor, the quality is undefined. And that's it.